Okay, everyone. Welcome back to the another session of this 5 days workshop. In last two sessions, we get to learn about the basics of telecommunication and mining infrastructure. In this session, we will get to know about this steel industry. The speaker for the session is Shri Aprup Bhattacharya, retired Deputy General Manager, Rourkela Steel Plant, and our alumni of 1976 batch of Mechanical Engineering. He has completed his bachelor's in the year 1976 and master's in Machine Design and System Analysis. He joined Steel Authority of India Limited, Rourkela Steel Plant in the year 1978 and superannuated as Deputy General Manager in charge of Design Department in the year 2015. He has an extensive experience of 10 years in the engineering division of Rourkela Steel Plant, especially in design of rolling mill and pipe plant equipments. At present, he is working in ITC Bilaspur. Previously, he has also worked with NIT Rourkela as an adjunct faculty. So, thank you so much for joining us for this session, and I request you to start the session now.
There is some problem in the audio, perhaps.
No, sir. Your
I am not able to hear continuously. There is some problem, perhaps.
Okay.
We are able to hear you.
Okay, I am starting. Okay, then I will start right now.
Yes,
so, I cannot say good morning right now. Good noon or namaste. So, in Hindi, there is no such confusion. It is always namaste. So, namaste to all. And welcome to this steel plant infrastructure. Now, many of you must have been and as such, a steel plant is a huge industry, very cost intensive. So this is it is a very complicated material flow. I'll try to simplify it. Stop me. I'll pause at any time. You can. So to start with, I have not made this presentation on PowerPoint because it looks to me a little monotonous. So I made it here. I think it will serve the purpose. Now, everybody, steel, all of you know steel, but technically, what is steel? So, of iron and carbon. Okay, so this is iron and carbon. Now, carbon is not chemically it is a solid, you can say an alloy. So, steel and alloy of iron and carbon containing less than 2 is important, and 1% manganese and small amounts of other impurities. Now, these things are very dangerous. So, there is an effort, a very elaborate effort in steel plants to contain the chemical. Now, this is obvious. Steel is the world's most important engineering and construction material. Every aspect of our lives. We used to have in our erstwhile company, Steel Authority of India Limited, a slogan that is a little bit of sale in everybody. So there is a little bit sale in everybody's life. Whether it is a safety pin or a watch band or whatever it is. So now sale is all about steel. About sale. So I will modify this. I will make it little bit of steel in everybody's life. The importance of steel is statement. Now we'll proceed. This was told by Henry Bessemer. All these things you must have read in your school days. I will not elaborate on this. The history. Now I will erase this thing. Confusion. Now, how steel is made. Now, steel is produced via two main routes. I will click the link so that the two main routes are visible here. So, I will enlarge it. Downloaded from world's the foremost body in steel industry. So, as I told you right now, first route means steel making through blast furnace. Another is electrical making. Now, in nature, steel is not available. What is available? So, ore is converted into steel by different processes. So that we will discuss as on this. And here also the ore, and then it is finally converting into steel. Now, once steel is formed, then you meet so that customer purchase. So I'll just no, these are two steel. From here, the process of giving different useful shapes begins here. This is called continuous. I will show you some videos also. Here we'll make some intermediate product. These are called semi-finished steel, slab, boom, all these things. They become the input material for further processing. For example, plates. Now, various places in making ships, then making your armor plates for combat railway wagons, and this second group is hot rolled and cold rolled strips coils. So this is coil of very maybe the weight may be around say 20 tons. So it is a long thin. Their end use are plenty. Most important is this making automobile body or LPG cylinders, your galvanized sheet, then other sheet metal products which you know, and then next jet is billet, and third is bloom. So billet is a smaller element and bloom is a larger element, but the cross section almost square or rectangle. Dimensions of blooms are more and billet is less. So this is converted into bars, building material. Saria can be made from this billet, and then you can make wires. Bloom, this is the third intermediate product. So from here you can make structural shapes like rod, all these, and you can also make rails, which is familiar to everybody. So this can be made from bloom. Steel plant, that is Bhilai steel rails only. So it has got some more product mix, but this is Bhilai steel plant is most famous for rails. Okay. So to the next. So this is all about, in brief, overview of. Now we'll come to all these aspects. So there are two main routes: blast furnace, basic oxygen furnace route, and electric arc. But I'll explain what are these. Now, the key difference between these two routes is the type zoom. For the that is BOF route, these are predominantly iron ore. You have iron ore, coal, while the EAF route, that is electric arc furnace, produces steel using mainly recycled steel and electricity. This is very much popular, EAF, because it needs a lot of electricity. Now, whenever electric arc started, it is so heavy that the line frequency, grid frequency goes down. Can you imagine? 50 hertz, when an arc, heavy arc furnace, the frequency of this AC goes down up to 47 hertz. So you can load. It is in megawatt. This is not very popular because in our country this electricity is not very cheap and plentifully available. Okay. So this figure shows that justifies the that is 70.7% of steel is produced by this method, and then rest is made by so now. So I'll not discuss the first. So most steel, this is very important. Why steel has become so popular? Because 100% recycled. Other, it may not be possible to recycle. For example, your other building material like thermoplastics, paper, or you cannot recycle it. Cloth, your kapda, you cannot recycle it. But steel, 100% recyclable. In products are recyclable, so they remain in use for decades before they can be recycled. So once it, you will not get enough steel for recycling. So this EAF steel making is also because recycled material is not available. So this is about the steel making. Now, how many types of steel are there? So, we can say, but it is a very wide category. As has been told here, there are more than 3,500 different grades of. Okay, now with many different and environmental property, you can have mild steel, you can have bulb steel, stainless steel, music wire, not. So there are number of grades. Now, one of the most important factors is the mechanical strength of the now approximately 3/4 of the modern steel have been developed in the past 20 years. So you can imagine how fast the growth happening. So definitely different grades of steel are being developed. Now, this statement, if the Eiffel Tower today, the engineers would only need 1/3 of the steel that was originally used. So you can imagine how it has taken place. So all of you know the Eiffel Tower. It is a huge construction. So at that time, steel technology was not so developed. They were so if you want to make another Eiffel Tower with present day technology, you need only 1/3 or even less. So the next is how much steel is produced in a year. So these are the figures: 1868.8 million. This is the unit used for steel production. The biggest steel producing country is currently China. So uh, this is a fact for almost half of the steel production, world steel production. Now, India is not, although the gap is quite high, but is second largest steel producer in the world. So we'll see one slide. Produce steel. So I'll just, you can see this is the chart taken from Wikipedia. So you can see here, is this much, then China is this, and India is this. You can see the gap. It is almost 1/9 one of the. Now this trend is happening. Only 18 it has become second, third, sometimes fourth, sometimes fifth. So as you can see the tremendous growth of steel industry in India. You can see 67, it was only 6.3 million. We have reached up to 110 million ton, 111.2 million ton. So the growth is exponential, and expect that it will. Okay, so these are the ranks of the different countries. You can see. You can see you can get this chart. You can get this chart in Wikipedia. So this is the situation of and where we stand. We go to the next. Now Indian scenario. As on September, downloaded from. I'll show you some route links also. So second largest producer in 219. So this is this much, and steel demand is 6%, and per capita steel consumption was quite low, almost one of the lowest. Now it has enhanced up to 74.10 kg. Now this happens only if development work take place. If roads are made, then only this goes up. Now this goes up means the economy of country is to know the one country. What is the steel consumption, per capita steel consumption? That is an indicator. Okay. So government steel is to increase the per capita steel consumption to 160 kg by 2030-31. It is long, but still the target is quite appreciable. So, and can be achieved. And this, anybody interested can be referred to this. You can download this. This Ministry of Steel. So this is the authentic document. So contents of the, so it can be anybody interested referred to this. So these are the authentic documents. Then another this. I will share all these. Listen, I'll share all this. So this is one document that is industry growth challenges and digital disruption. So this is also a very good document where entire scenario steel production. For example, this is our steel industry, how it has grown over the years. It started in 1875, 1937, and TISCO started in 1907. Then here it was ISCO, Indian Iron and Steel Industry. Then to completion of Durgapur, Bhilai and Rao. These are all the milestones. And in 2018, India becomes the world's of crude steel. So lot of diversions, lot of meanders, but end result is very good. We are at a particular place in the world. Quite good place, you can say. So this can be referred to if anybody is interested. Overview of steel. I have shown you. I'll show you again. So this chart you have seen. I will not go much into. Then, having said that, because I have spent much time in Rourkela steel plant, so I will describe Rourkela steel plant. It is the process in all the steel plant. There is a slight variation in the finishing portion of the steel plant because the product is not same in all. For example, this Rourkela steel plant resume of Rourkela steel plant. This is the resume of Rourkela steel plant. Actually, it started in It started in 1953 with an agreement with two German firms, namely Fried Group and so they were responsible for developing the plant. Now the document or agreement was signed in 1953. In 1950, the construction complete and this lighting of the first blast furnace, Parvati, by the President of India on 3rd February 1959. So this is the first blast furnace in India. The Rourkela steel plant is the first integrated, which was inaugurated on 3rd February 1959. So, and there are many things. For example, this is the first, then first LD technology. I will explain what is LD technology. This was first time in Asia and world. At that time, this technology was, but still we took risk, and this is one of the, this is the only technology now available for steel making. LD technology obsolete. So we'll now this, after this Parvati, there are other blast furnaces, Lakshmi, Saraswati, etc. Durga, all those things, Annapurna, all these things have been added subsequently. So I 20 million ton capacity, 1.0, and now after modernization, it has become 4.5 million ton capacity. It has gone at par with. Okay. So now steel, this Rourkela steel plant is called the product mix. The product mix of Rourkela steel plant, they are basically, they are called product mix of Rourkela steel plant. They are basically called flat products. Means generally plate, strips, then pipes. The pipes are made from flat product. So Rourkela steel plant is known for flat. So we'll see the product mix, total bag of the product that we will see. I'll show you right now. This product mix, I'll show you right now. See, Rourkela steel plant. This is available in our sale website, Government of India. So this is the product mix. You can see. So these are the capacities. Then hot rolled plates, hot rolled coils. Then now Rourkela steel, the oldest producer of large pipes. So we'll see how the pipes are produced. Then spiral weld pipes, roll sheets and coils, then galvanized sheets, all these roofing sheets. The pioneer is Rourkela. Then silicon steel sheets. Now, little explain this. Those electrical engineers know it, that this appliance, the core is made of For example, in a transformer, the core and there is a secondary winding. Okay. Particular thing is called this is called core. Now this core is not made solid. Why it is not made solid? Because of AD current losses. Means there should not be any much difference and power out. So if this is made of solid steel or solid iron, then there will be huge eddy current losses. So these are layers, stampings. You must have seen. Now, in order to control the eddy current, these laminations, high silicon steel, because silicon provides the necessary specific resistance in this, so that limit the eddy currents. Now this one is made in this one. This product is meant for stampings. Now these stampings are made, then your all motors, fans, generators, everywhere, all electrical machines are using this silicon steel. That is a that product, and Rourkela Steel Plant is the pioneer in this, and this is the capacity here, and rest of the products, you know, it is. So what are the uses of different products? You can see HR coils are used in automobile, railway wagon, chassis, and all types of high strength needs. Then plates, pressure vessels, shipbuilding, and engineering structures. Checker staircase in the industrial installation. CR sheets and coils, these are the uses. All these things you can see. Then, so these are the, then electrolytic tin plates that you know, all the Amul milk, everybody has used Amul milk, then Milkmaid, they are all made of these tin plates. All तेल का जितना canister आता है, they are all tin plates, having huge demand. So on steel, so these are the stampings, rotating movement, relays, etc. So these are the product mix of, and each one is having huge demand. So I'll close this. Now I come to the technical part of my. Now first we'll iron making. What is iron making? Making is basically an ore. We'll see. Now I am resuming my technical portion. That was the. So the iron is made in blast furnace. So, and what is blast furnace? So we'll go to steel making. Now, the purpose of a blast furnace is to chemically reduce and physically convert iron or liquid iron called hot metal. A term in steel plants, hot metal. Now, this hot metal is the liquid iron which comes out of. Now, as such, this is a use. It has got very inferior properties, so it cannot be used anywhere. Okay, but this is the starting material. steel making. So it has got a great importance in steel industry. Okay, so I will come to this again. The blast furnace diagram. This is the blast furnace. It is a huge, tall structure, maybe 70, 80. Now, here you see, this is the top portion. This is the top portion from the in fed. So incoming charge is what? This is iron ore, then coke, and I'll explain each one of that. So they are placed in layers. One layer is iron ore, one layer is coke, another layer is limestone. Again iron, limestone. So they are alternately laid one after another. And from here, hot is introduced at around 1000 degrees centigrade. Now from where we get that air, I will show you. So this hot air below, these are called tuyeres. I will write down. This is called tuyeres. TUYERS. So these are the openings from where the hot air is introduced. And now when it goes inside, some chemical reaction takes place. So you can see at the top, let us say, see, hot air reacts with coke. So this is carbon dioxide, then carbon dioxide is split carbon monoxide. Now this is very poisonous gas, carbon monoxide. So this is actually responsible for iron ore, which is generated at the bottom of the blast furnace. Through these reactions, they upwards and then react to iron ore, which is there at around 700 degrees centigrade. So reduction of iron ore, so it liberates the iron CO2, and there are some impurity. So that limestone decomposes and slag is formed. Means limestone reacts with other impurities, etc., and they form the slag. Now, once the iron is formed, it comes down, and as the temperature, it becomes liquid and it settles down here. This is called the hearth. So trickles down into this hearth as a molten iron, and slag also is trickled down and impermeable layer, because less than iron, so it is floating on the iron. And it has got another important that is, it isolates the air, otherwise it will again get oxidized. So this is the process of, and at a fixed iron is taken out, slag is taken out, so that this becomes empty. And because this is a continuous process, so intermittently iron slag is taken out. Now this ascent, the descent journey of the iron ore and coke and limestone, it 12 घंटा, 12 hours journey. In 12 hours, this thing, the iron is formed. So this is, then I'll show you the material, the logistics. You can see it here. So this is the blast furnace. So this is the main furnace which I explained you earlier. Then these are the logistics: coke, lump, ore, limestone, means of skip. So there is a small wheel, small vehicle, a car-like thing, iron ore and other charges into the belly of the furnace. Now from here, this cold air is fed into some which heat the air. So this hot blast goes into the tuyeres, and this is the air supply system, and this is the this is called cast house, from where the tapping is taken. Hot metal slag is taken out, and then it is sent for further processing. Okay, so these are the further processing unit. Now, one byproduct which comes out of is carbon monoxide. Now this has got heating properties, means it can be used as fuel. Now we will be the entire steel industry, blast furnace gas as it is called, because all the furnaces, other furnaces, the rolling mill, where this gas is burned to heat. So this is an important byproduct. This saves a lot of money in terms of coal or coke fuel as a fuel. This is cleaned and then it is sent for further consumption, clean gas to various units of the. Okay, so this is the logistics of steel plant, blast furnace area. Now, one important coke oven, means where coke is the, you know all what is coke. Coke is the heating of coal. Air remains absent. There is no air. It is heated in a closed chamber, and the impurities. Now coke is percent carbon, and coal contains a lot of impurities like volatile matter, then all these things. So that cannot be put in. So you have to make it pure carbon. So that is done by coke oven. Now I'll show you one video. This coke business is. So this is the coke oven battery. Sorry. I'll again put it. So these are the coke oven battery. You will understand when it shows it the cross section. So this is the cross section. Now this coal is charged from the top. The coal is charged. It is a closed chamber. Cross section has been shown. Now heating takes place inside. Now this heating is done by those. So now the coal is heated and matter escapes through this pipeline. Okay. So after it escapes, the hot is pushed into a car. This is hot coke car, and then it is sent to the tower. Here, spray place for about 90 seconds, because if water content is more, then it will not work. So dry up. So this is it has been quenched by water spray, and that coke is ready for play. So this is the then we'll see some more sketches, some more videos. So this is the charging side. This is the charging pit. This is the now this will go up and pour the material here inside. You can see as the video. So more coke, and this is the calcium. So, now this goes and then pours the material inside the blast furnace. So this goes on and on and on. 24 hours. The functioning of the blast furnace. I'll again come back to that document. So these are the compositions which is there already. I'll share all these things. Anybody? So these are the chemical compositions, and this is the typical composition of a hot metal. Iron is 93.5 to 95. Then silicon this, sulfur this, etc., etc., etc. So these a lot of impurities are there in hot metal. So hot metal. Steel making is basically purifying all the impure things, impurities in the hot metal is taken out, and only a carbon and other impurities remain in the final product. So we'll see what is steel making. Before that, the logistics of the converter I will show you. So this is a huge vessel, like a you can say a cooking ware, you can say. A huge. The weight of this is around 8 tons. It is a huge vessel. I'll show you the video also. Now here, hot metal is added, lime is added, dolo is added, one of the raw material, dolomite. Then this is called, so this is called lance. This one is called lance. Lance means it is a pipe through which it's blown into this. Okay. We have learned about Bessemer converter. In Bessemer converter, air is blown from bottom. This is the LD process which started way back in 50s. So this is the first experimental setup in Asia, and third. So this is the LD process, filled with raw material and blown by oxygen, and this when oxygen comes into contact with steel, it is exothermic reaction, produces, and it also consumes the other impurities like carbon, silicon, phosphorus, sulfur, all those things. So this, these are the output. Then slag and some gas is also produced. So these are the logistics of the LD vessel. Now, show you another link. So these are the chemical reactions which take place. So this is that in which the hot metal is poured, oxygen is blown through it. So these are the impurities which go away after all. So, and these are the slag, that is the metal, and they go to the atmosphere. So these are the, and what is left is pure steel. So this is hot metal, this is steel. Now this steel is removed from the vessel. The vessel can be tilted. Here, this you can see. So this can turn, it can tilt. This is a huge vessel. Okay. The inside is full of steel. It will be poured. So here the blowing is over. Now it will be, first the slag will be removed, then iron steel will be removed. Now slag is coming out from here, and then it away to take out the steel. You can see. So this is how the LD vessel is. So this is the hot metal, etc. is poured into this. You can see the hot metal is poured into the LD vessel. So this is poured, and up out the lance will be lower, blowing will start. So this is how LD vessel is working. Okay. So made, this is called semi-finished steel. Uh, those intermediate steels are made from here. Now there are like ingot making, big mill. Then the recent method of converting the semi-finished steel uh, from this raw steel, that is liquid steel. Casting. Now continuous casting, I will show you what is continuous casting. See the steel into this ladle, that is the steel has come hot steel from LD vessel. Now then it is put on a continuous casting setup. You can see here. So this ladle is, now this ladle is placed on the, this is called turn disc. This is called turn disc. UNDISH. So So after it is poured into tundis, more stream of hot metal goes in mold. So it goes into the mold, and from here it comes out as it, and as it goes down, it solidifies. So initially in the top it is liquid, which is guided by the mold, and then when the mold it becomes semi-solid or plastic. Then it further goes down and it solidifies, and these are the blooms or billets, whatever you call. So when it comes down to when it becomes sufficient, they are cut and they are supplied to the rolling mill. So here at the bottom solidified. So this is cut. Though cutting car is also moving with that, so that they cut it at a particular length. You can see. So these are the blooms. Now that is here, and then it is sent for further processing. So these are the billet, semi-finished steel. So this is the billet which will be further processed in rolling mill for the cross section and making it some useful material. So this is the roll and see. So this is all about continuous casting. Will from continuous you get from here you get semi finished steel like slabs, booms, billets. Okay, so these I have shown you in the big setup. So semi-finished steels need further processing, which is done in rolling mills. Now the principle for you here the video. So the rolling mill, two rolls, उसी प्रकार से. So here you can see hot slab is baलन and the length increase, the grain structure becomes refined. So you can see the grain structure becomes refined here. You can see here. So it improves the mechanical strength also, and the length also gets increased. You can see. Okay. Is the hot rolling and another is cold rolling, where the rolling process takes place in cold conditions, and this is how it is done. Okay, so here also same thing happens. So this give you a small tip that hot rolling is done above realization temperature, which is around 7 for steel, and cold rolling is done below recrystallization temperature. That is, in metallurgical terms, it is called AO. Okay, so this is how it is differentiated. All right. So these are technical things. I don't want to go in further details. So hot rolling and cold rolling is done. Okay, so then another video showing plate. Show you. So this is the basic principle. See here, the width is this much. Now after rolling, it becomes this much. Okay. Incoming material is shorter and out longer, and thickness goes down. Okay. So this is the basic principle of plate mill. It is done plate mill and strip mill made. So I'll show you another video. Hot strip rolling. So this is the furnace where the cold slabs are heated, reheating furnace. Now this is blast furnace gas. So slabs are then this is called descaling. Now why descaling? Because it comes out from the furnace, it comes in contact with scales are formed here. So those scales are removed by high pressure air jet. High pressure. So here the surface is clear water, and then it goes to the roughing mill. This is slightly reduced. The length is increased. So 2-3 passes, length increases, and then it stand again. And this is the uh, cooling. So then it goes to the uh, cold by now, so they are heated by blast furnace gas. Then it goes to the shear for, and then it goes to the thickness gauge finishing. So you can see this is finishing line. Use further and further. You can see that thick slab has become a strip now. A very strip. So this is the cooling section where metallurgical properties are given. So the strip is cooled here. It goes to the gauge where thickness etc. is measured. So, and after that, it is sent to the coiler where it is stored in form of coils. You can see the coil. Now this coil is the incoming material for many other units. So from hot strip mill, you get coils. So from hot strip mills, you get coil. From plate mill, you get. Now these coils are fed to pipe plants for making pipes. So from these pipe plants, you get pipe. So I'll show you how you are getting this. Electric resistance welding. So this is the strip coil which has come here. So this is gradually, see, this pipe is being formed gradually, passing through some forming rolls from all the sides. You can see. After it is completely formed, high frequency electric current is coil, which then joins the seam. You can see, and a pipe is formed. You can see. So this is called electric resistance welding. So this is done in Rourkela steel plant. So the pipe sizes. So this is how you are. Okay. So I'll close this. Then this is from ERW. You get pipes 8 5 by 8 inch, 20 inches pipes, and in 10 to 12 meters. This is the limit because any structural or pipe cannot be made more than 12 meters because it will come. So they are made of this length only. The method of pipe making is spiral weld. This SW stands for spiral weld pipes. Now this is from 20 inches to 64 inches, and length is same 12 meter. So this is the length range, diameter range of spiral welded. Now how it is made, I will show you some video. So this is how spiral pipe is made. So this is the feed, and by changing the angle you can make any. Okay. So this is the feeding strip and this is the output pipe, and these are the joints. Now this is aluminium for steel. Okay. So the pipes are made. Okay. So this is another. So this is how spiral pipes are made. I am closing this video. Just now in spiral pipe, what happens? This this is the, say this is the central pipe. This is there. So this is the spiral. So this strip side, this is the width of the strip and this is the diameter. So there is a trigonometric relationship between D and W. This angle is important. this angle. This is the incident angle. Now, if you bring down this angle, so this is how spiral pipes. And another mill is that cold rolling mill. Now, cold rolling mill, I have not because it is same as hot strip mill. Rolling is done at room temperature, much below the recrystallization temperature. And silicon mill is a type of cold rolling mill. It is called silicon mill because the input material, the input slab, high silicon content. Input for silicon mill content 1.12% silicon. So that's why it is called silicon mill. For stampings, used for stamp, as I have explained. So I have covered in brief. Actually, it is so complex and so vast, sufficient, but I have tried to make it. Certain things may not be clear. Now I'll ask you to with me, and you can ask any questions if you want, or I conclude with this. So,
any participant want to ask something?
Yes, sir. What is the
I have to
relative
show this.
disadvantage of hot and cold rolling, sir? Because what I feel, the cold rolling will take a lot of power.
Yes, in hot, yes, it will take a lot of power. You are right, but then the qualities are much superior compared to hot, and you can get thinner gauges. For example, in hot strip mill, the minimum roll is around 6 millimeter.
Yes.
Cold rolling mill, you can go up to 0.6 mm also. So they are used, they have their own uses. The tin made by cold rolling, because that thickness cannot be made by hot rolling.
Yes.
Any other participant want to ask something? Okay. DP ma'am, are you there?
Yes, sir.
Sir, one small question, sir.
Sir wants to ask him. Yes, sir.
Sir, one more small question. Sir.
Yes,
Do
yes.
these, do these plants like
Yes.
Raurkela, do they make their own electric power, or they take supply from the electricity boards or central sector? Because it is a very power consuming process. Now.
Yes. Right. You are very correct. Actually, Bhattacharya steel plant started with one captive power initially.
Okay.
When it was 1.8 million ton stage. It was having what capacity small power plant. Then as the modernization started, the capacity went up. Another power plant, 20 megawatt capacity. that was subsequently separated from our from SAIL, and it joined NTPC. It is called NSPCL now. That is working under NSPCL, but still having two also sometimes it becomes very difficult to manage. Connected to the eastern grid. Okay, so our the production do not match with our or buy. We purchase electricity from eastern grid.
Yes. It's a lot of waste recovery. Heat goes in waste. I think a lot in these plants. So they must be using many heat recovery methods also.
Yes, you are right. Have come up during the last modernization, because this technology was in 50s when plant started.
Yes, sir.
Didn't bother about these recoveries and environment and all those things. So they have come later on. Now, if you go right now into this aspect, such recovery technologies operating in you sometimes you may have some boilers also which process steam purpose, not for power generation.
Yes.
Steam is generated from waste heat.
It can only
There are
be
many
done
places.
in the design stage actually.
Yes.
Thank you, sir. Thank you so much, sir.
Gurdeep Singh Bagga, sir.
Welcome. You are welcome.
You want to ask?
Hello. Sir, am I audible?
Yes, sir. Yes.
Sir, I wish to ask how to control the pollution, like industrial work, it's the industrial process of producing steel. So it is related to the environmental of your. It is the policy of the government also say that 10% of the waste will be disposed and 90% will be reused or recycled in some way. So, what are the methods which is applying in the industrial area? Reuse or reduce the pollution.
Okay. So your question parts. So see, there are solid pollutants and gas pollutants. Okay. The solid waste is of slags and fly ash. Okay. Now slag is nowadays sold as building material for roads. And fly ash is used for making bricks. So that is also given free of cost. Cost is borne by the purchaser if you given free of cost. And the liquid waste nowadays very have come, so that plants have come up where the water is treated before it is released in is like rivers or ponds. So they are biologically treated. They are the biodegradable which will degrade the pollutants. And as far as the pollution is concerned, when I joined in some 40 years ago, anybody, if you have gone to Rourkela on those days, sky was almost red. I think our principal, because he has studied in Rourkela, the skyline of Rourkela, it was almost pink. Now almost, it is as clear as a lot of pollution control has taken place. These electrostatic precipitators, etc., have been put. Government guidelines are very strict, and they are actually, when I was working, there was a dictat also that if these are not met, the plant will be closed. Parameters
thank
were
you,
taken
sir.
into account. Okay.
Thank you, sir. Thank you so much for your response.